Hey Math 3 students, how's it going? We have now kind of wrapped up Unit 8. Hopefully you've kind of figured out all of that testing and kind of see how we're going to do tests now, and we are diving in with Unit 9. Unit 9 is on periodic functions. It's an abbreviated unit since we are doing this remote learning, and who knows how much we're going to have to pare it down. So what does periodic mean? Well, periodic, you may hear when someone says periodically or something like that. It's a function that repeats its values in regular intervals or periods. And you see that word in your everyday life. Okay, for example, you may have lunch at the same time every day. Now, this is probably in a normal school day, right? Right now, maybe you don't. Maybe you don't have lunch at the same time, but in a normal day on like a Monday, Wednesday, well, not Wednesday, Monday, Friday, you'll have lunch at the same time. So you have it same value, right? Anything that goes in a circle. If I were to put my cursor here, the baby hits the cursor and goes back around and comes back to the same value. So that's periodic. And the last example of periodic is anything that goes in a pendulum motion. Okay, so our little Frogger guy, if I put my cursor here, hits the value again and again and again. Okay, so what does this look like if we were to graph it? If we were to graph this, it looks a little bit something like this. Now we're going to get to graphing later on in the unit, but I just wanted to give you a snapshot of what the graph of a periodic function looks like. The value repeats itself time and time again. So now let's back up. We need to learn some trig before we can move forward with our periodic functions. Now, some of you have learned this before, and some of you this is new, but we have 6 right triangle trig functions. So if we have our right triangle that you see on your screen here, we know that the long side is the hypotenuse. If we're looking at an acute angle, meaning it's less than 90 degrees, the opposite side is just, of course, opposite that angle, and the adjacent side is right next to it. So our trig functions, we've got sine is the opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. Then we have these other 3 that are just inverses of the sine, cosine, and tangent. The CSC stands for cosecant. SEC is secant, and this is cotangent. So a good way to remember this is SOHCAHTOA. So maybe you've heard this before. But SOHCAHTOA stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And again, then the other 3 are just inverses. Okay, so what I'd like you to do is pause the video and write this in your toolkit if it's not already. Now that it's in your toolkit, we're going to do some practicing. So let's evaluate the 6 trig functions of this angle. Okay, so the first one is sine. Now I will already say I apologize for my writing on this. It's pretty terrible, but let's see how it goes. So if I want to evaluate the sine, I know that the sine is the opposite over the hypotenuse. The opposite of the angle is 15, and the hypotenuse is 17. All right, now let's do cosine. Cosine is adjacent over hypotenuse. Problem is we don't have the adjacent, but we can solve for it. We all remember the Pythagorean theorem, right? So the Pythagorean theorem, if I call this x, I can say that x squared plus 15 squared is equal to 17 squared. When I solve that, x is equal to, I believe it's 8. Yes, that's an 8. So my cosine now, remember, is adjacent over hypotenuse, will be 8 over 17. Okay, and the last one, my tangent, I'm going to do this over the side so I can show my inverses. The tangent is opposite over adjacent, so 15 over my adjacent, which is 8. Okay, now I'm going to do my inverses in blue. So the inverse of sine is cosecant. I know it's tempting to say secant because they're both with an S. Remember that it's just the opposite of that. So all I'm going to do is flip the numbers. 17 over 15. The inverse of cosine is secant. 17 over 8 and my cotangent then will be 8/15. Okay, so those are my 6 trig functions of that angle. What I'd like you to do now is pause your video and try this out on your own. Evaluate the 6 trig functions of the angle. Now let's see how you did. Okay, so what I'd like you to do now, match your answers with mine. How'd you do? Okay, remember, if you have a question, you can always email me a question, or you can even comment and say, wait, how'd you do that? Moving right along. We can use this idea of special right triangles to calculate missing side lengths and angle measures. So in this triangle here, we have a 45-degree angle and a 90-degree angle. We know that the sum is 180. 180 minus 90 gives us 90. 90 minus 45. We know that this last angle here is also 45 degrees. Because those angles match, we know that this is called an isosceles triangle. So those sides must be congruent. So therefore, this side is also 8. So we could figure out what the hypotenuse is by, again, using the Pythagorean theorem. We could say 8 squared plus 8 squared is going to give us x squared. Okay. Well, 8 squared is 64. I'm going to actually do this one out. 64 plus 64 will give us x squared. So that's 128. It's an 8. Okay. So x would be the square root of 128. Well, 128 is 64 times 2, and the square root of 64 is 8. So it turns out, right, that this is 8 times the square root of 2. So now what do you notice between all of the side lengths that we just solved for? They all have an 8. So this is one of our special right triangles, which is pretty cool. In a 45, 45, 90. So if we know that this is 45 and we know that this angle is 45, what happens is that the sides of the triangle will be congruent, but the hypotenuse will be that number times the square root of 2, which is pretty cool. But we have another special right triangle. We have a 30, 60, 90. So let's take an equilateral triangle here, meaning that all of the sides are congruent. And I'm going to split this in half. Okay. Now, if I look at the little triangle that I just made, I'm going to make this blue triangle. Okay. The bottom is 1 since I cut it in half, and the hypotenuse is 2. I can use that same concept and solve for the altitude. I can say that 1 squared plus x squared is going to give me 2 squared. Okay. Well, 1 squared is 1, so x squared is going to give me 3. 2 squared minus 1 squared. So therefore, x is the square root of 3. So this creates our second special right triangle pattern. Okay, that looks like this. If we have x at the bottom here, the hypotenuse is actually double whatever that is. Again, if we scroll back, once we cut that in half and we have 1 here, if we double that, we get our hypotenuse. And the altitude will be whatever that base is times the square root of 3. So again, I would like you to pause the video, and write this in your toolkit if it's not already. All right, how can we use this? Let's practice finding the missing side lengths using this idea of 2 special right triangles. This first triangle, the first thing you want to do is identify, is it 45, 45, 90 or 30, 60, 90? The 60-degree angle gives it right away. We have a 30, 60, 90. So because I know this is a 30, 60, 90, let's go look back to our rule here, okay? If I look back at my rule, just like you have in your toolkit now, across the 30 angle is just x. Across from 60 is x times the square root of 3, and across from 90 is 2x. So now as we look at our example here, we can kind of correspond that. We can say, all right, this was across from 30 was our x, this was 2x, and this was x times the square root of 3. So applying that, if x is 30, 2x, which is our c, is going to be 2 times 30, which gives me 60. Now b then, I'm going to take my x, which is just 30, and multiply it by the square root of 3. Now I'm going to leave it with the square root since that is kind of in most exact form. So I can just leave it like that. All right, pause the video again and try some of these on your own. Let's see how you did. Okay, I'm going to move this little guy in case that's in your way. This one's a 45, 45, 90. This is actually the one that we did together. So you should get, whoops, you should get A is 8 and C is 8, the square root of 2. Here we have a 30, 60, 90. So you should get that B is half of the hypotenuse, is 6. So therefore the altitude is 6 times the square root of 3. And this last one may have been a little challenging. It's a 45, 45, 90, but we know the hypotenuse, okay? So now what we actually have to do is do a little bit of thinking, okay? We know, let me see if I can write on this. We know if this is x and x, that this is x times the square root of 2, okay? So if 50 is x times the square root of 2, to solve for x, I need to divide by the square root of 2. So I know that x is 50 divided by the square root of 2. Now I don't like that square root of 2 in there. So what I'm actually going to do is multiply the top and bottom by the square root of 2. Okay? These ones actually cancel out. Okay? The square roots do. So I'm left with 50, the square root of 2, divided by 2. And we know that 50 divided by 2 is 25. And we get our lovely answer down here. Okay? All right. So what I'd like you to do, congratulations, you made it through our first kind of lesson, our first kind of video lesson. So if you want more resources, you can go onto 8.1 in your Math 3 book, which you can either find through Clever. So hopefully now that we've been through Clever, you kind of see how that works. And then I'd like you to do Clever 8.1 Homework 1. So the link is in our Google Classroom, and you should be able to access that and get that done. If you have any questions, feel free to reach out.